In this video, we'll look at scientific notation. Look at what is scientific notation and why we use it, and then how we can convert numbers between scientific notation and standard form, and then back the other way, standard form to scientific notation. So here are three numbers that are written in scientific notation. Read this as 2.21 times 10 to the 9th power. That's the number of seconds we have in a year. That's a really big number. Or about 3 times 10 to the 8th meters per second. That's the speed of light, right? Really fast. And then 1.67 times 10, and pay attention to the negative 24th. That negative is cluing me in that it's a really small number, which we'll get to later, but that's the mass of a hydrogen atom. So why do we use scientific notation? Well, just like we saw here, we want to use scientific notation to express really large or really small numbers rather than writing all those zeros and things like that. And then what does it look like? Well, look at all these numbers here. For a number to be written in scientific notation, the first factor must be between 1 and 10. That's these numbers here. These are all between 1 and 10. And then what do you notice about the second one? That second factor has to be a power of 10. 10 is the base, and then it's raised to some power. All right, let's take a look here. Which numbers are written in scientific notation? Remember, for a number to be written in scientific notation, the first factor is between 1 and 10. Second is a power of 10. They're factors, so we multiply factors together. We're multiplying those two together. A is written in scientific notation. That first factor is between 1 and 10, and the second is a power of 10. Can you find the other number that is written in scientific notation here? If you said it was E, you are correct. First factor is between 1 and 10. The second is a power of 10. C is not right because that's not a power of 10. B is not right because this is not between 1 and 10. D is not correct because you're dividing. And for scientific notation, we multiply those two numbers together. And F is greater than 10, that's 70. So that's not scientific notation. All right, let's convert these from scientific notation to standard form. I think about scientific notation as the numbers kind of compact, and then in standard form we can expand it out. So like a slinky all together, and then when we go to standard form, we spread it out, okay? So we're gonna see how these numbers look different, yet they are the same value. These four numbers here are all written in scientific notation. 3 times 10 to the 8th, well, we know 10 to the 8th is just 10 to the 8th power is 100 million. Well, what's going to be 3 times 100 million? We know that's going to be 300 million, right? But notice what we do. That's a 3, and then followed by 8 zeros because we're moving the decimal point to the right 8 times. 4.88 times 10 to the 3rd. Well, 10 to the 3rd, I've got my 4.88. 10 to the 3rd is 10 times 10 times 10. That's 1,000. When I multiply 4.88 times 1,000, I move that decimal point to the right 3 times. 5.75 times 10 to the 4th. 5.75. 10 to the 4th is 10,000. If I multiply something by 10,000, that decimal point is going to move over 4 times to the right. 5, and then here's the first time, second decimal, third, and fourth. I use those zeros as placeholders. 57,500. Notice what I did for all of these problems. The number of times I moved the decimal to the right is the same as the exponent there. So when I change 2.1 times 10 to the 5th to standard form, I'm taking that number that's squished together and I'm expanding it out. I'm going to move that decimal point 5 times to the right. So 1, 2, 3, 4, 5. And all these empty spots I'm filling in with zeros because they're my placeholders, and my decimal is at the end there. So what do I have? I have 210,000. And I'm going to mark that clearly so it's easy to see. So remember what we're doing. We're taking our first factor, we're looking at the exponent in the power of 10, and that's telling us how many times to move the decimal point to the right. All right, let's go the other way. Let's go from standard form to scientific notation. So standard form, the number's expanded, right? It's bigger. In scientific notation, we want to push the slinky together. We want to contract it. So 3,000. Well, in that number, 3,000, where's the decimal? We don't see it. Where is it? It's right here at the end. So in order to get my first factor, that first number between 1 and 10, I need to move the decimal point over 3 times, right here between the 3 and the 0. That line, I encourage you to do it. It helps me visualize where the decimal goes. It goes after that first digit, the 3. And then I know for scientific notation, I need to multiply by 10 to a power. Well, what's the exponent? Again, this is why the diagram helps me. I can just say, hey, I moved that decimal over 3 times. So my exponent has to be 3. That's how many times I moved it over. 67,600. Here's where the decimal is. To get this first factor between 1 and 10, I've got to move this decimal over here between the 6 and the 7 at the end there. So this is going to be 6.76. I know I've got to multiply by 10 to a power. What's the exponent? Well, I move the decimal 1, 2, 3, 4 times, so it's 10 to the 4th. And then finally, 19 million. Well, the decimal is here. I've got to move this decimal all the way over between the 1 and the 9 to make the first factor between 1 and 10, 1.9. And this is going to be multiplied by 10 to some power. What's the exponent? 1, 2, 3, 4, 5, 6, 7, 10 to the 7th power. All right, here are a couple for you to try on your own. I'd like you to convert these first two to scientific notation. So you would move the decimal between the 6 and the 8. This would become 6.89 times 10 to some power. Got to move that decimal over 5 times 10 to the 5th. In number 2, the decimal's got to go between the 7 and the 6. So now you've got 7.6 times 10. And how many times did you move that decimal? 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th. And now we're going from scientific notation to standard form. Well, I've got 4.21 times 10 to the 4th. I know I've got to use my digits, 4, 2, and 1. I got to multiply by 10 to the 4th. I need to move the decimal over 4 times to the right. So it's going to be 42,100. And last, I've got 9 times 10 to the 6th. Well, I've got my 9 here. I need to move the decimal over 6 times. Since there's nothing here, I know that it's just going to be 6 zeros that act as placeholders. So 9 times 10 to the 6th is 9 million. And that's how we work with scientific notation.